Welcome to Intelligence Gateway.
Module 3, Backup and Recovery. Backup Strategies and Tools. Backup strategies and tools are essential for ensuring data protection and data recovery in PostgreSQL. Here's an overview of backup strategies and commonly used tools in PostgreSQL. 1. Backup strategies. There are several backup strategies that can be used in PostgreSQL, depending on the requirements of your application and the level of data protection you need. Some commonly used backup strategies include full backups. This involves making a complete copy of the PostgreSQL database, including all data, indexes, and configuration files. Full backups are the most comprehensive form of backup and provide the fastest recovery time in case of data loss. Incremental backups. This involves backing up only the changes made since the last full backup or incremental backup. Incremental backups are more efficient in terms of storage space and backup time, but they require additional processing during restore to apply the changes. Differential backups. This involves backing up only the changes made since the last full backup. Differential backups are similar to incremental backups, but they are based on the last full backup instead of the last backup, making them easier to restore. Point-in-time recovery, PITR. This involves creating a series of incremental backups that allow you to restore the database to a specific point in time. PITR is useful for applications that require the ability to recover to a specific moment in time, such as financial applications. 2. Backup tools. There are several tools available for creating and managing backups in PostgreSQL, including pg_dump. This is a built-in PostgreSQL utility that allows you to create logical backups of PostgreSQL databases. It creates a SQL script that can be used to recreate the database, including all data, schema, and configuration. pg_dump. This is a variant of pg_dump that allows you to create logical backups of all databases in a PostgreSQL cluster, including user roles, table spaces, and other cluster-wide objects. pg_base backup. This is a built-in PostgreSQL utility that allows you to create physical backups of PostgreSQL databases. It creates a binary copy of the database files, which can be used to restore the database to its original state. Third-party backup tools. There are also several third-party tools available for creating and managing PostgreSQL backups, such as Barman, pg_backrest, and pg_probackup. These tools offer additional features and functionalities, such as compression, encryption, and incremental backups, that can enhance the backup process. It's important to regularly schedule and perform backups according to your application's requirements and data protection policies. Additionally, you should also test your backup and restore procedures to ensure that you can successfully recover your data in case of a data loss event. Point-in-time recovery, PITR. Point-in-time recovery, PITR, is a feature in PostgreSQL that allows you to restore a PostgreSQL database to a specific point in time, using a series of incremental backups. PITR is useful for applications that require the ability to recover to a specific moment in time, such as financial applications or other time-sensitive data. PITR relies on the concept of transaction log or write-ahead log, WAL, in PostgreSQL. The transaction log is a sequential log that contains a record of all changes made to the database, including insertions, updates, and deletions, in the order they occur. By leveraging the transaction log, PITR allows you to recreate the database state at a specific point in time by applying the changes recorded in the transaction log. The basic steps for performing a PITR in PostgreSQL are as follows. 1. Enable and configure the PostgreSQL transaction log. To enable and configure the transaction log, you need to update the PostgreSQL configuration file, postgresql.conf, and set the appropriate values for parameters such as wall_level, archive_mode, archive_command, max_wall_senders, and wall_keep_segments. These parameters determine how the transaction log is managed and archived. 2. Create and manage incremental backups. You need to create and manage a series of incremental backups of the database using tools such as PG_base backup, PG_dump, or third-party backup tools. Incremental backups capture the changes made to the database since the last backup, and they are used in conjunction with the transaction log to perform the point-in-time recovery. 3. Restore the database to a specific point in time. To perform the PITR, you need to restore the database to a specific point in time by applying the incremental backups and the transaction log. You can use tools such as PG_CTL or PG_WALDump to apply the transaction log and restore the database to the desired state at the specified point in time. PITR provides a powerful mechanism for recovering from data loss events or rolling back the database to a specific point in time. However, it requires careful management of the transaction log and incremental backups, as well as thorough testing of the restore process to ensure its effectiveness. It's important to understand the PITR process and practice it in a controlled environment to ensure that you can successfully recover your data when needed. Disaster recovery and high availability. Disaster recovery, DR, and high availability, HA, are critical considerations in any production database environment, including PostgreSQL. PostgreSQL provides several features and options for implementing DR and HA strategies to ensure the availability and reliability of your database even in the face of catastrophic events or hardware failures. Some of the commonly used DR and HA techniques in PostgreSQL are: 1. Replication. PostgreSQL supports various forms of replication, such as physical replication, streaming replication, and logical replication, also known as logical decoding. Replication allows you to create one or more copies of the primary database, known as replicas or standbys, which can be used for failover or disaster recovery purposes. Replication provides high availability by allowing automatic failover to a standby database in case of primary database failure, and it also enables off-site backups for disaster recovery. 2. Backup and restore. PostgreSQL provides built-in tools such as PG_dump and PG_base backup for creating backups of the database. Backups can be used for disaster recovery by restoring the database to a previous state in case of data loss or other catastrophic events. It's important to regularly schedule and test backups to ensure their integrity and effectiveness for disaster recovery purposes. 3. Continuous archiving and point-in-time recovery, PITR. PostgreSQL's transaction log or write-ahead log, WAL, can be used for continuous archiving, which allows you to create a series of incremental backups that can be used for point-in-time recovery, PITR. PITR allows you to restore the database to a specific point in time, providing fine-grained recovery options in case of data loss or other issues. 4. Failover and load balancing. PostgreSQL supports various load balancing techniques such as connection pooling, partitioning, and distributed queries, which can be used to distribute the workload across multiple database servers for improved performance and availability.
Thanks for watching. For more information, like, comment, and subscribe our channel.